Okay, we're going to start with page 6 for Trig Id, and we're going to prove some more of these, proving left hand side equal to the right hand side. So I'm going to start with number 6. So as you can see, for this one, we always talk about starting with the more complicated side because it's easier to simplify the complicated side. So we will start with the right hand side. So we will keep the left hand side as it is, because we'll have to ultimately prove that the right hand side is equal to this left hand side. So there are different strategies, and one of the strategies is, remember what I said, when you see a tan square, or any square actually, any square, and if it's in, with another, like here in this case +1, if there are 2 terms, they can be reduced to 1 term if you can apply Pythagorean ID for that specific combination. So I'm looking at tan square x plus 1. So I want you guys to look at the Pythagorean ID and see if this will, I can replace this with some 1. So tan square x plus 1, so I am seeing, so I like to have this with me. I like to write it down so I can quickly look at it. So I do have 1 plus tan square x equals secant square x, so I'm going to replace this with secant square x, and I'm going to leave this for now as cosine square x minus 1. And the strategy I used, the reasoning was Pythagorean ID. And then I'm going to keep my left hand side as is, and then I'm going to see, so secant square x stays as secant square x, and cosine square x minus 1. I'm going to again look at my Pythagorean ID and see if there's anything that I can do. So cosine square x minus 1, but here I see 1 minus cosine square x. So what I can do is I can pull out the negative 1 out of this and rewrite this as 1 minus cosine square x. So negative 1, and then the negative 1 becomes positive. Remember when I said when you pull out the negative, each of the term has an opposite sign because you're dividing by negative. So negative 1 becomes positive, and cosine square is positive, it becomes negative. And then basically the reason was I factored negative 1. So that was the reasoning for step number 2. Step number 1, step number 2. Okay, there's not enough space, but yeah, we'll keep going till we completely run out of space. So I keep this as negative tan square x, and then I basically bring the negative in the front, and then keep this as secant square x, and then 1, I just saw in my Pythagorean ID 1 minus cosine square x equals to sine square x, so I replace this with sine square x. Now I'm again doing Pythagorean ID because this replacement is Pythagorean ID. Okay, so I'm just going to use another piece of paper and continue. Step number 4, this one, my left hand side stays as is. Okay, so now I want to see how I can simplify this. So remember, one of the strategies we talked about is to convert everything to sine and cosine. So which basically means I can convert secant square x as, remember secant is 1 over cosine, so this can be written as 1 over cosine square x, and this is sine square x. And from step 4 to step 5 I did the reciprocal ID. Everybody good? Because basically from here to here it was reciprocal ID. And now I know that if you want to write it in a simplified form, tan square x equals, I can leave it like that, but there's a little more clarity if I can write it sine square x over cosine square x. And basically I just did, you can say simplify, multiply, any of those things. And now my step number 6 should give me my final answer. So this side stays as is, and we know that sine square over cosine square is tan square because of reciprocal ID, so negative tan square x. So I got my answer, but what did I use from here to here? I used quotient ID. Of course, so that is the first problem in page number 6. In 6 steps, I proved left hand side is equal to the right hand side. Okay. Alright, now I'm going to move on to problem number 7. So I'm going to, since the lack of space, I'm just going to rewrite it. So tan x plus cotangent x equals, there's a multiplication, I think it's not very clear, but that's secant x. Okay, so we can do either. The only problem with this is I can do reciprocal ID, and I'm not sure if I can get to this. I'm not sure if I can get to this, because this will be written as 1 over cosine, this will be written 1 over sine. Okay, I'm not sure. So I'm going to try to work with the left hand side in this case. So now I'm going to try to convert this to, so I'm going to work with the left hand side, and tan x can be written as sine x over cosine x, and cotangent x can be written as cosine x over sine x. And I'm just going to bring this down. I'm just going to say right hand side, just easier. I'm just going to continue the right hand side instead of writing it every time. I'm just being lazy, that's all. Now remember, you're adding fractions. So for me to add fractions, you need the same denominator. So my denominator will be cosine x multiplied by sine x. So here I need sine x, so top and bottom with sine x, and here I need cosine x, right? That's how I get my common denominator. So my common denominator is going to be sine x cosine x, right? Both the denominators are the same. And my numerator is going to be sine x multiplied by sine x is sine square x, and cosine x multiplied by cosine x is cosine square x. And then I need to prove that equivalent to the right hand side. Okay, let's keep going. From here, so step 1, step 2, step 3. So if I look at my Pythagorean, so now I have squares. So if I look at my Pythagorean ID, I know that the first Pythagorean ID is something that we should be really familiar with. We talked about it that this is the one that we need to make sure we know. Sine square x plus cosine square x equals to 1, because that's our original one. So I can go ahead and replace this with 1 over. Okay, so one thing I do realize that I did not write the steps for the reasons for each one of them. So this one is just, so from tan to sine to cosine and cotangent, they were both quotient ID. I'm sorry, I'm forgetting. Step 1 is quotient ID, and step 2 is just simplify or adding fractions, add. Or you can just say simplify. If it's not one of the IDs, I can take different answers. You can say simplify, you can say multiply, you can say add, depending on what you're doing. They are more algebraic steps. And now I'm replacing sine square x plus cosine square x with 1, and my denominator is sine x times cosine x, and I need to prove that equivalent to secant x cosecant x. And this time I won't forget, my ID is going to be, because I replace cosine square x with 1, that is Pythagorean ID. I shouldn't have forgotten. Oh, there we go. Sorry, you couldn't see it. And then I can, what do I notice here? 1 over sine x and 1 over cosine x can be written as, basically 1 over sine x is cosecant x or secant x, and 1 over, so basically secant x and basically I used 1 over sine reciprocal ID. So that is my number 7, proving left hand side equals to right hand side in 4 steps. Yeah, I hope that's clear. Okay, let's go on to problem number 8, and let's see how we can do problem number 8. And as you're watching this, you can probably hit pause and see if you can do this yourself before coming. If you are not able to, you can come back and play and see how I did it, or you can play and check whether what you did is right. learn that way too. Okay, so again I'm going to start working with my left hand side, because that seems to be the more complicated side. I can make that equal to sine x, but 1 minus cosine square x, I'm going to go back and look at my, maybe I can replace this, and I'm going to look at my Pythagorean ID statements that I've written down. 1 minus cosine square x is sine square x, so this one is really straightforward. So I replace that with sine square x, and then this is cosecant x, and the right hand side stays as it is. And I used, from going from here to here, I used Pythagorean ID. And then I'm going to leave sine square x as sine square x, and cosecant I know is the reciprocal of sine, so I'm going to write this as 1 over sine x. So I went from here to here using reciprocal ID. And then we know that sine square, this can be simplified. This gets cancelled, so I'm just left with sine x. And this side is just sine x. All you did was to simplify. So in step 1, step 2, and step 3. So step 1 was Pythagorean ID, step 2 was reciprocal ID, and step 3 was just simplifying to get my final answer. I'm sorry. We will stop and we'll pick it up again.